Hello mathematicians, puzzlers, and other curious people. We're here in this video with the goal of fully factoring a trinomial. In this case, the trinomial 6x squared minus 21x minus 12. So one thing I notice about this trinomial right away is that all of its coefficients are multiples of 3. So although you can do this in either order, it's easier if you start by factoring out that greatest common factor first. So I'm going to start by rewriting this as 3 times 2x squared minus 7x minus 4. Okay, now I will be carrying that 3 along as an outside factor all the way through. And now here's what I know. Or at least if this is factorable, here's what I expect to see. So I'm expecting to find out that if I box out a multiplication of two binomials, something x there also, and then some number, and did that multiplication, I would get 2x squared here and negative 4 there, and when I combined my like terms, I would get negative 7x. Now the big question is, how did I get that negative 7x? Was it negative 3x and negative 4x? Or was it negative 10x and 3x? That's the hard thing to tell. So it turns out there's a good way to help us out with that. So I'm just going to give these some temporary names. I'm going to call that A, B, C, and D. And here's what I'm asking you to notice here. Here we have that 2 being A times C. Here we have that negative 4 being B times D. So if we multiply those together, we would get A times C times B times D. So we've got A, B, C, D there. Well, if we multiply this and this together, whatever they may be, well, I know that this would be B times C, and this would be A times D. So if I multiply those together, I'd have B times C times A times D. Those are the same. That's important. So if we split that middle term, it comes out to some factor pair for the first times the last. So that's an important thing I want to write down. So when we've got first, middle, and last, well, if we split that middle term, that comes out to, I'm going to call them M1 and M2. Okay, so if we have our first times last and make an ordered list of factor pairs, middle 1 and middle 2 have to be in there somewhere. And that is what we're going to use as the key insight that will let us factor this. So let's multiply first times last. So 2 times negative 4. Okay, so that's just simple math, good old integers. Positive times negative is negative. 2 times 4 is 8. Okay, so let's think about how we can multiply and get 8. We'll deal with it being negative in a minute. So then we could do 1 times 8, or 2 times 4. 3 doesn't work, and then we're in repeats, so those are all the options there are. Okay, but then one of them has to be negative. Well, I noticed this comes out to negative, so I want to assign the negative to the bigger one. So now what sums can I get? So remember, if we imagine that 2 and negative 4 are middle 1 and middle 2, when we combine them to get that actual middle coefficient, we would get negative 2. Well, that's not what we had in mind, but 1 and negative 8 would give us negative 7. So that tells me middle coefficients 1 and 2 are actually going to be the numbers 1 and negative 8. That tells us how we can split that middle term. This is awesome! Okay, so let's split that middle term from negative 7x to x minus 8x. See how if we combined those like terms we would get negative 7x? And then let's bring in the rest of the problem around it. So we'd have 2x squared plus x minus 8x minus 4 in there and bring along the 3. Now I know this looks even worse than it did when we started, right? So many things going on, but we're actually much closer to an answer than we were at the beginning. So I'm going to tidy this up a little bit. And now we know things. So we know that there'd be a plus x and then minus 8x in there. Okay. So now I'm going to look at what's called factoring by grouping, and I'm going to take these pairs 2 and 2 how they are. I'm not going to, mess with the order of them any. And I'm going to say, okay, well, I see that these two have a common factor of an x, so I'm going to factor that out. So then that leaves behind 2x. Now remember, since we've factored everything out of this term, we need to put a plus 1 for the term representative. And then over here, I notice both of these are negative, so I know I'm going to factor out a negative. And I notice they're both even, so I see I could factor out a 2. Let's see, and then that would give me 4x plus 2. Now that didn't match yet, and we really want those to match, so I'm going to look a little harder. Oh, of course, 4 and 2 are both still even, so I didn't factor out a big enough number. So I notice actually they're both multiples of 4, so I'll go ahead and factor that out. If you get to that step and they don't match, look and see if what you factored out is really the greatest common factor within that little group there. So now I'm leaving behind 2x plus 1, and then still bringing along the 3 outside. Actually, to make that easier to distinguish, I'm going to use the square brackets there. They work the exact same way, but it's just convenient to make them visually different. Okay, we're done with this really. I'm going to scoot that down. And we've used this as much as we're going to also. Okay, so now here's what I notice. We've got a thing that matches, which is good. That's exactly what we want. So now that we've got that thing that matches, we can factor it off. And I'm going to put that 2x plus 1 up front. And then I'll write their term representatives in parentheses. So we'll have x minus 4. And then we can bring along the 3. At this point, I'm choosing to drop that outer set of brackets there because everything's just being multiplied anyway, so we don't really need a grouping symbol in the middle to maintain the value. Okay, so what's really going on here? Well, we found 2x plus 1 and x minus 4. So let's see. We know that one of the things that went into getting that 2x squared, well, there had to be a 2 and a 1 to get a 2. That's because 2 is prime. So I notice that it can't be over here because then this would have to be a 2. So it must have been there. Well, and then let's see, 2x times something to get negative 8x. Well, that had to have been negative 4. And then on the other hand, x times something to get x, that had to have been positive 1. 2x plus 1. X minus 4, just like we see here. You don't have to fully do it both ways, but it can be a good way to just check your work. Make sure that it came out reasonable. So this right here would be my final answer. But speaking of checking work, there's another way we can do that. So I'm switching over to the green because we're going to verify that this is correct. So I'm going to start by just trying to multiply this out, and I'm going to multiply it in a different order than I did before. I'm going to start by multiplying on that 3. So let's see, 3 times 2x would be 6x. 3 times 1 would be 3. Okay. So then where we've got 6x plus 3 and x minus 4, we can go ahead and multiply that out. And we would get 6x squared plus 3x minus 24x minus 12. Certainly this is the 6x squared that we can see right here. Let's see, negative 24 plus 3 would be negative 21, and of course that's with an x, which matches what we wanted to see here. And then negative 12 also matches. So since this multiplies out correctly, I'm going to say not only is this my final answer, but I believe it is a full credit answer. So that is a way you can deal with factoring trinomials anytime you need to.